Okay, good evening, students. Today we are going to discuss the convolution in inverse Laplace transforms. So we know the importance of Laplace transform. That is, Laplace transform is a mathematical tool which is used in the solving of differential equations by converting it from one form into another form. Generally, it is effective in solving linear differential equations, either ordinary or partial. It reduces an ordinary differential equation into algebraic equation. Ordinary linear differential equation with constant coefficients and variable coefficients can be easily solved by the Laplace transform method without finding the general solution and the arbitrary constants. It is used in solving physical problems, this involving integral and ordinary differential equation with constant and variable coefficients. So we also know that it's also used in convert the signal system in frequency domain for solving it on a simple and easy way. It has some applications in nearly all engineering disciplines like system modeling, analysis of effective circuit. It's an system modeling and digital signal processing and nuclear physics. Next, process controls, applications in probability, applications in physics, applications in power system, load frequency control, etc. So, the convolution is also a very important useful mathematical tool. So, convolution is used for obtaining inverse Laplace transform of product of two transforms solving ordinary differential equations. So what is the definition of convolution? So we can select the color of the pen. Okay. So the definition of convolution is let f of t and g of p, two functions, for t greater than 0, we define the product f of t star g of t is equal to integral 0 to t f of u g of t minus u du. This is the definition of convolution. So product of two functions is equal to integral 0 to t f of u g of t minus u du, assuming that the integral on the right hand side exists. And this product f of t star g of t is called the convolution product of f of t and g of t. It can be proved that convolution product is commutative and convolution product is associative, and also true for f of t star 0 is equal to 0 into f of t is equal to 0. So what is convolution theorem? If Laplace transform of f of t is f of t and Laplace transform of g of t is equal to g of p, then Laplace transform of f of t star g of t is equal to f of p to g of p. So we know the Laplace transform of one function and also Laplace transform of another function, then we can also easily find out the Laplace transform of product of those functions. We know that the Laplace transform of f of t is equal to integral 0 to infinity e power minus pt f of t dt, that is our f of p. Similarly, Laplace transform of g of t is equal to g of p, then Laplace transform of the product is equal to f of p dot g of p. Or simply applying inverse Laplace transform, that is L inverse of f of p dot g of p is equal to f of t star g of t. This theorem proof it is easily proved using the standard definition of convolution, also in Laplace transform definition, that is integral, that is Laplace transform of f of t is equal to integral 0 to infinity e power minus pt phi of t. So phi of t can be taken as product of two functions. So simply it is very easy to prove the convolution theorem. So we are directly going the applications of convolution theorem, that is using convolution theorem, find L inverse of 1 by p plus a into p plus b. So 1 by p plus a into p plus b, it is clearly we can easily see that 1 by p plus a into p plus b can be written as 1 by p plus a into 1 by p plus b. That is so product of two functions. So let f of p is 1 by p plus a and g of p is equal to 1 by p plus b. So apply inverse Laplace transform. So L inverse of f of p is equal to L inverse of 1 by p plus a, which is equal to e power minus at. Next, L inverse of g of p, that is L inverse of 1 by p plus b is e power minus pt. So these two are our f of t and g of t. So by applying convolution theorem, that is L inverse of 1 by p plus a into p plus b is equal to L inverse of 1 by p plus a into 1 by p plus b. That is L inverse of f of p into g of p. Using convolution definition, this can be written as product of two functions f of t star g of t. That is integral 0 to t f of u g of t minus u du. So integral 0 to t, so f of t, we know that f of t is e power minus a t. So f of u is e power minus a u, and g of t minus u e power minus b into t minus u. Just replace t minus u in the place of u. So we are integrating with respect to u, that is e power minus bt is constant. So integral 0 to t e power minus of a minus bu du. So we know the integration e power ax dx is equal to e power ax by a. Using the integration of exponential function, we get e power minus of a minus bu by minus of a minus b. So apply limits, upper limit minus lower limit. We get minus of a minus b e power minus bt. So apply t in the place of u, we get e power minus of a minus b into t minus lower limit is apply 0 in the place of u, we get e power 0, that is equal to 1. So therefore the result is this one. Next, what is the inverse Laplace transform of 1 by p into p square plus 4? So clearly can be written as f of 1 by p into 1 by p square plus 4. So let f of p is 1 by p and g of p is 1 by p square plus 4. L inverse of 1 by p is 1 and L inverse of 1 by p square plus a square. So we know the standard formulas, that is 1 by p square plus a square is equal to 1 by a sine ad. That is 1 by 2 sine 2t. So applying convolution, that is L inverse of 1 by p into 1 by p square plus 4. It is in the form of L inverse of f of p into g of p. That is definition of convolution, f of t star g of t is equal to integral 0 to t f of u g of t minus u du. That is integral 0 to t. So f of t is 1, so f of u is also 1. G of t minus u is, g of t is 1 by 2 sine 2t, so g of t minus u is 1 by 2 sine 2 into t minus u du. So what is integration of sine? That is minus cos. So sine 2 into t minus u integration is minus cos of 2 into t minus 2. The differentiation of 2 into t minus u is minus 2. So now apply upper limit minus lower limit. So we get 1 by 4. So substitute t in the place of u, that is t minus 2 0, we get cos 0. And lower limit is t minus 0, we get cos 2t. So cos 0 minus cos 2t, cos 0 is 1 minus cos 0. So we get this result. Next, using convolution theorem, evaluate L inverse of 1 by p into p square plus 2p plus 2. So clearly let f of p is 1 by p. So L inverse of 1 by p is 1 and L inverse of 1 by p square plus 2p plus 2 is g of p. So this p square plus 2p plus 2 can be written as 1 by p plus 1 whole square plus 1. So many problems we did in this method using partial fractions are also and first shifting theorem. That is 1 by p plus 1 whole square plus 1. So using first shifting theorem, what is first shifting theorem? L inverse of f of p minus a is equal to e power at and f of t, or L inverse of 1 by p plus a, f of p plus a is equal to e power minus at f of t. So that is L in here p plus 1 whole square plus 1. So here p plus 1 is there. So using first shifting theorem, we get e power minus t L inverse of p square plus 1. So p square plus 1 is sine t. So we get g of t is e power minus t sine t. So using convolution theorem, so L inverse of 1 by p into 1 by p square plus 2p plus 2, it is in the form of f of t star g of t. So it is commutative. Convolution is commutative, so g of t star f of t. So using the definition of convolution, integral 0 to t g of u f of t minus u d. That is integral 0 to t. What is g of t? E power minus t sine t. So we get e power minus u sine u. F of t is 1, so f of u t minus u is also 1. So integral 0 to t e power minus u sine u d. So we know the formula e power ax sine bx dx is equal to e power ax into a sine bx minus b cos bx by a square plus b square. Using this formula, e power minus u by a square plus b square is 1 plus 1 and a is minus 1 minus sine u minus cos u. So apply limits 0 to t, upper limit is e power minus t sine t plus cos t minus lower limit is 0. So sin 0, 0 plus cos 0 is 1. So we get 1 minus e power t sin t plus cos t. Next one, using the convolution theorem, find L inverse of 1 by p square plus a square whole square. So clearly we can observe that this is a product of two terms, that is 1 by p square plus a square. So f of p is 1 by p square plus a square, g of p also 1 by p square plus a square. So find L inverse of 1 by p square plus a square is 1 by a sin a t. Similarly, g of p, L inverse of g of p also 1 by a sin a t. So we get f of t 1 by a sin a t, g of t also 1 by a sin a t. So now L inverse of p square plus a square whole square is equal to L inverse of p square plus a square into 1 by p square plus a square. That is L inverse of f of p into g of t. So using the convolution definition, we get product of two functions f of t star g of t. Using the convolution definition, that is integral 0 to t f of u g of t minus u du, that is integral 0 to t. What is f of u? F of t is 1 by a sin a t, so f of u is 1 by a sin a u. G of t minus is 1 by a sin a into t minus u du. So 1 by a square. So sin a sin b. So it is in the form of sin a sin b. So sin a sin b. So we know that how we get this formula. So we know that so cos of a minus b. Cos a minus b is equal to cos a cos b plus sin a sin b, and cos of a plus b is equal to cos a cos b minus sin a sin b. Just subtracting these two get cancelled. So subtracting subtracting minus plus, these two terms get cancelled. We get 2 sin a sin b. 2 sin a sin b is equal to cos of a minus b minus cos of a plus b. So like this we get. So 2 sin a sin b is equal to cos of a minus b minus cos of a plus b. So applying this formula, so we get here a is au, b is at minus au. So cos of a minus b. So au minus at plus au. So we get 2au minus at minus cos of a plus b. So we get cos at. So now integrate. So different integration of cos is sin 2au minus at by. So we get differentiation of 2a minus 8 is 2a minus integral cos 80. So integral cos 80. So here cos 80 is constant. We are integrating with respect to u. So cos 80 into integral du, that is u. We get u. So now apply limits, upper limit minus lower limit. So 1 by 2a. So replace t in the place of u, 2at minus 80. So we get sin 80 minus cos 80 into t. So t cos 80 plus lower limit is apply 0. So minus sin 2a 0 minus 80 minus cos 0. Cos 80 into 0, so it is 0. So we get 1 by 2, that is 280 minus 80 is 80. So 1 by 2 is sin 80. So simply, so LCM is 2a cube. So 2a cube. So we get sin 80 minus 80 cos 80. Next, apply convolution theorem to evaluate L inverse of 1 by p minus 2 into p plus 2 whole square. So let f of p is 1 by p minus 2, g of p is 1 by p plus 2 whole square. So L inverse of 1 by p minus 2 is e power 2t. L inverse of 1 by p plus 2 whole square is applying first shifting theorem. So using first shifting theorem, e power minus 2t L inverse of 1 by p square, that is 1 by p square L inverse is t. So t e power minus 2t. So using convolution, that is L inverse of 1 by p minus 2p plus 2 whole square can be written as 1 by p minus 2 into 1 by p plus 2 whole square. That is L inverse of f of p into g of p. That is f of t star g of t. So using convolution definition, integral 0 to t f of u g of t minus u du, that is integral 0 to t. What is f of t? So f of t is e power 2t. So f of u is e power 2u. G of t. G of u is t e power minus 2t. So we get t in the place of t, we get t minus u e power minus 2 into t minus u du. That is e power minus 2t. So integral 0 to t, so e power 2u, here also e power 2 e power 4u, we get t minus u du. This is e power minus 2t using the product form, that is integral f g dx is equal to f into integral g dx minus integration by parts, that is f into integral g dx minus df by dx integral g dx whole dx. Using this formula, we can solve this one, that is t into integral 0 to t. First function is, what is the first function? So t minus u, t minus u integral 0 to t power 4u du minus integral 0 to t. So differentiation of t minus u is equal to minus 1 e power 4u du. So using the formula integration by parts, we get this one. We get this. Okay. So next is after simplification, we get these terms. That is 1 by 16 e power, applying limits also, applying upper limit minus lower limit after simplification, we get these terms. Okay. Or this problem can be easily solved using this method also. So alternative method is, let f of p is 1 by p plus 2 whole square and g of p is p minus 2. So then Laplace transform of L inverse of f of p is 1 by p plus 2 whole square, that is applying first shifting theorem, we get e power minus 2t and g of t is e power 2t. So using convolution theorem, we get e power minus 2u and u e power 2 into t minus u du. So it can be easily integration by parts. It is simple way. So better to take f of p. F of p 1 by p plus 2 whole square and g of p 1 by p minus 2. So we get easily and quickly the answer. Next, using convolution theorem, find L inverse of p by p square plus a square whole square. This is a very important problem. So L inverse of p by p square plus a square whole square. So clearly, we can write this is a product of two terms. So let f of p is equal to p by p square plus a square and g of p is equal to 1 by p square plus a square. So L inverse of f of p is L inverse of p by p square plus a square, that is cos at. That is our f of t. Next, L inverse of g of p is L inverse of 1 by p square plus a square, that is 1 by a sin at. So this is g of t. So by using convolution theorem, we get L inverse of p by p square plus a square whole square is equal to cos at into 1 by a sin at, that is 1 by a cos au sin a into t minus u du. So it is also like this, cos a sin b. So cos a sin b formula is 2 cos a sin b is equal to sin of a plus b minus sin of a minus b. So integral 0 to t sin of a plus b is au plus at minus au and sin of this. So for simplification, we get sin at, this AU get cancelled. So sin 80 minus sin of 2AU minus 80d. So 1 by 2 here, sin 80 into u, sin 80 integral. Sin 80 is constant. We are integrating with respect to du. So integral du is u. 1 by 2a. So integral of sin is integral of sin a. So cos integral of sin is minus cos 2au minus 80 by 2a. So applying limits 0 to t, we get t by 2a sin 80. If we take a is 1, then L inverse of p by p square plus a square is simply t by 2 sin 2. So next, what is L inverse of p square by p square plus a square into p square plus b square? That is L inverse of p by p square plus a square into p by p square plus b square. So f of p is p by p square plus a square. Simply the L inverse of p by p square plus a square is cos a t, and p by p same p by p square plus b square is cos bt. So f of t is cos a t, g of t sin bt. So applying convolution, we get f of t star g of t, this cos a t star cos a t star cos bt. That is integral 0 to t f of u cos a u g of t minus u, that is cos b into t minus u du, that is 2 cos a u cos b into t minus u. We know that cos a cos b formula. So what is cos a cos b formula? Cos a cos b formula. So we know that cos of a plus b, cos of a plus b is equal to cos a cos b minus sin a sin b. cos of A minus B is equal to cos A cos B plus sin A sin B. Just adding these two get cancelled. So we get 2 cos A cos B is equal to cos of A plus B plus cos of A minus B. So 2 cos A cos B formula is cos of A plus B plus cos of A minus B. So using this formula, so cos of AU plus BT minus BU plus cos of minus BT plus BU. So A is AU, B is BT minus BU. So we get like this. So cos of A plus BU minus BT. So integration of cos is sin. Sin of A minus BU plus BT by A minus B. Sin of A plus BU minus BT by A minus B. So applying upper limit minus lower limit, we get these two terms like this. So then sin AT 1 by A minus B minus 1 by A plus B and sin of A plus B minus AB. So we get this term. So if we put A is equal to 2 and B is equal to 3, we get the L inverse of P square by P square plus 4, P square plus 9 is minus 1 by 5, 2 sin 2t minus 3 sin 3t. If we put A is equal to 2 and B is equal to 5, we get P square by P square plus 4 and P square plus 25. That is 1 by 25, 5 sin 5t minus 2 sin 2t. Since L inverse of 1 by P square is t, L inverse of 1 by P plus 2 whole square is first shifting theorem, e power minus t. L inverse of 1 by P square, that is t, t e power minus t. So using convolution theorem, that is L inverse of 1 by P plus A whole square into 1 by P square. Using convolution theorem, we get integral 0 to t. So what is f of p? So f of p is equal to 1 by p plus a, p plus 1 whole square. That is L inverse of f of p. L inverse of f of p is equal to L inverse of 1 by p plus 1 whole square. That is equal to, using first shifting theorem, e power minus t, L inverse of 1 by p square. That is equal to e power minus t into t. We get t e power minus t. It is f of t. So what is g of t? G of t is equal to 1 by p square. So g of p is equal to 1 by p square. So L inverse of g of p, which is equal to L inverse of 1 by p square. So which is equal to t. This is our g of t. So using convolution theorem, we get, which is equal to f of t star g of t star g of t, which is nothing but integral 0 to t f of u g of t minus u du. So which is nothing but integral 0 to t f of u is equal to u e power minus u, j of t minus u is equal to t minus u. So after integrating and applying upper limit minus lower limit, we get this. So next, what is 1 by p into p plus 1 into p plus 2? So it can be written as 1 by p into p plus 1 into 1 by p plus 2. So consider 1 by p into p plus 1, we can consider 1 by p into 1 by p plus 2. So first of all, find, using convolution, we find the inverse Laplace transform of these two functions. There is L inverse of 1 by p is 1. We know that L inverse of 1 by p plus 1 is e power minus t. By using convolution, 1 by p into p plus 1 can be written as e integral 0 to t. That is f of u, that is 1, g of t minus u, that is equal to, what is our g of t? E power minus t. It is e power minus t minus u. After integrating and applying 0 to t, we get e1 minus e power minus t. Now the second part is 1 by p plus 2. So L inverse of p plus 2 is e power minus 2. And again, using convolution theorem for these two functions, that is L inverse of 1 by p into p plus 1 into 1 by p plus 2. So this is our f of, now our f of t is this one, and g of t is e power minus 2t. For these two functions, using inverse convolution, that is integral 0 to t e power minus 2 into t minus 2 1 minus e power minus f du. That is equal to, after simplification, we get e power minus 2t e power 2u minus au du. That is e power minus 2t integral of e power 2u is e power 2u by 2 minus e power u. Apply upper limit minus lower limit, we get this. The result is 1 by 2 plus 1 by 2 e power minus 2t minus e power 2t.